All right, everyone. In this video, we're going to work through material from Module 27 on intelligence. So first off, just jumping right into this idea, this construct of intelligence, controversial and a lot of debate on what constitutes intelligence, what it means to have intellectual capacity, concerns that is this a sort of a biased type of thing, and sort of definitely concerns about how we go through and measure it. But from a psychological standpoint, when we're talking about intelligence, again, no one definition, but generally what we're talking about involves the capacity to learn, problem solve, and then utilize knowledge to adapt to novel situations. Okay, so when we're talking about intellectual capacity or intellectual capacity or intelligence, again, your ability to go through and adapt to different situations, problem solve, some creativity and things like that going in. And so because this is a super complicated construct, there's a lot of different components that go into overall intellectual capacity. We'll get into this towards the end of the lecture, different theories of intelligence, and again, a lot of debate on what we should count as facets of intelligence, but generally agreed upon that this is something that contains multiple different skills, although those skills are generally highly correlated with one another. Okay. Now, an intelligence test. This is going to be any type of instrument that you use to look at mental ability. But again, this is the important thing about this based on reference to a larger population. So there are all sorts of, if you go through the internet, sort of on your Facebook feed, sort of things that you can click on, says, take this intelligence test, see if you're a genius. None of those are real. Those are super fake. It's to get you to go through and sort of try and sell you things and all of that. Real validated intelligence tests or cognitive achievement tests, these are things that are probably some of the most tested and most highly developed instruments that we have in terms of pinpointing validity and reliability of intellectual capacity. And what these scores are always doing is they're normed relative to the general population. Okay. And so if I get a score on one of these instruments, what it is, it's telling me where I rank relative to people in general. Okay, so it's not just a raw score. Built into that is where I stand relative to, say, the average person. Okay, and lots of testing goes into these, lots of development. So super huge area of psychological research. So these types of tests are going to be different than what we would see from the normal types of exams that we take in day-to-day stuff. Okay, these generally fall into one of two categories: either an aptitude test or an achievement test. Okay, aptitude tests, these are instruments that are intended to predict your ability within some sort of specific domain. Okay, so these are things like your SATs, your ACTs. When you get into graduate school, your graduate record exam, your GREs. The idea is that you take ACT, SAT, and that's telling you or trying to predict ability to sort of go on, be successful in university, higher education, things along these lines. Okay, it's kind of getting at stuff that you learned in high school, but it's more about going through and predicting sort of future success. Okay. Now, achievement tests, these are instruments that are designed to assess specifically information that you've learned. They're not necessarily intended to predict anything. They're just intended to assess sort of whether or not you know sort of material that's been delivered. Achievement tests, these are going to be things like, if you graduated from Wyoming, the proficiency assessment for Wyoming students, your PAWS exam coming out of high school. If you're from back east, Regents exams, our quizzes that we take in this. These are achievement tests. We go through and say, here's information and modules, and then I develop an evaluation to see whether or not you sort of have a good grasp of that information. This is going to be an achievement test. Okay. Now, our intelligence tests, these are going to be different. We're going to talk a little bit more about some of the technicalities of this later on, but we see that intelligence is expected to be correlated with performance on aptitude and achievement tests, but they're not the same thing, okay? If my capacity to problem solve, utilize knowledge, adapt to situations and things like that is high, I'm expecting sort of my ability to sort of my predicted ability within certain domains and my ability to acquire and sort of utilize knowledge that's been presented, the stuff that we're getting on an aptitude and achievement test, to be higher. They're not perfectly correlated. They're not the same thing, but generally we would expect an association there. Yeah. Now, before we get into this, so we want to go back through and review correlations. We had talked about this towards the beginning, or at the beginning of the semester, when we're talking about research methods and things. Remember that a correlation, and our correlation coefficient is indicated by this R symbol here. Our correlation tells us, it gives us a measure of the extent to which two variables are associated with one another. Okay, so if I look at say height and weight, as people tend to get taller, they are bigger people, they tend to weigh more. It's a correlation between those two. Okay. And so our correlation coefficients range from -1 to 1. As close as we get, the closer we get to -1 or 1, the stronger that association is. So if I have a correlation of -1, that means perfectly as x increases, or one variable increases, it perfectly predicts decreases in the other variable. If I have a perfect correlation of +1, it means as x increases, it perfectly predicts y as y increases. And so as we get closer and closer to -1 and 1, reflecting a stronger relationship, as we get closer and closer to get 0, indicating no relationship. X and y are unrelated to one another. Okay, so this correlation coefficient, R, right here, this tells us both the magnitude or the strength of an association and the direction. Okay, so again, for example, here, X is perfectly correlated with Y. X and Y are correlated, would have an R value of 1. If I know what X is, I can perfectly predict what Y is going to be. It's a perfect straight relation, so this was going to be a positive correlation. If it was a perfect negative relation, as X would increase, Y would decrease, right? You think negative correlation, think frequency of smoking cigarettes and life expectancy, let's say, right? Smoking is bad for you. The more and more and more I smoke for the longer period of time, the lower and lower life expectancy is. So as X cigarette smoking increases, life expectancy Y decreases. So that would be a negative correlation going in the opposite direction. Not a perfect correlation, but that's what a negative correlation would look like. So here we have a perfect positive correlation. Okay. Another example here, X and Y in this graph, completely unrelated, right? The best line that I could draw through this is probably just a flat line going across here, indicating that X and Y are completely uncorrelated. This would be a correlation that's very close to, if not exactly, 0. Okay. Here, again, we have height and weight. Height and weight pretty strongly correlated. This is a correlation of 0.8, right? So we see as height increases, we see weight tend to increase. It's not perfect, but it's a pretty strong, we can see a clear correlation right there. Here, correlation between, from one semester, quiz 1 and quiz 4, same type of thing. We see a pretty decent positive correlation. It's not perfect, but definitely we see a trend as performance on quiz 1 increases, at least in this semester, quiz 4, score on quiz 4 increased here. Okay, so all of these indicative of an association between two variables, but remember that correlations only indicate an association, not that one thing causes another thing. Very important to remember. Correlations give us a measure of the extent to which two variables are related, does not mean that one variable causes another variable. That's the big thing that you need to watch out for anytime you see correlational research. Doesn't mean that X causes Y, it just means the two things are associated. Okay. So, getting back to intelligence, sort of starting off at the beginning, person generally credited with sort of the father of intelligence tests is a gentleman named Alfred Binet. And Alfred Binet was called upon by the French government in beginning of the 20th century to start to evaluate achievement in French children. What the French government had decided, very progressive at the time, is that all children of France should receive public education. And so what they did is they went through and brought kids all over the country into a public education system. But what they found very quickly is that some kids do very, very well. Other kids struggle, right? And what they wanted Binet to do was come through and identify kids that were in need of additional help, okay? Wanting to help, and again, this is super progressive for being at the beginning of the 20th century, wanting to find those kids that maybe were performing and be able to predict and identify these kids that would need extra help, maybe sort of extra time, resources, things along these lines, okay? And so what Binet did is he walked into this with a certain theory, and Binet's theory on intelligence or intellectual capacity was that all children follow basically the same trajectory. But what Binet felt was that some kids just develop more quickly than other kids, okay? So if we plot this out, if we say, okay, down here on the x-axis is age, y-axis is ability, what Binet's thought and his sort of his theory or assumptions of intellectual capacity is that everybody falls along the same trajectory. All of us, anybody like me, anybody you know, we all fall along this general trajectory. And now Binet was looking at sort of elementary school kids, so younger kids. But what Binet felt was that on average, there was some point on this trajectory where the average 4-year-old performed, let's say. And there was some point on this trajectory where the average 8-year-old fell. So higher than 4, 8-year-olds are here. And then let's say somewhere on this line, sort of 11-year-olds are functioning right here. And so over the course of development, everybody follows this trajectory. But Binet felt that just some people and some individuals, particularly if individuals who are gifted or those who may struggle a little bit, start to hit mile markers or start to hit points a little more quickly versus people who might struggle may hit things at a later time. And so what you could have is, say, someone who was 8 performing at the average level of an 8-year-old, but could actually be younger than 8 or maybe older than 8. Okay, but the idea is everybody followed the same trajectory. We just get to different points on that trajectory sooner or sometimes sooner or later than the average person. Okay. So, and there's 11. So, what Binet did to try and tease this out, and super smart. What Binet did was started to put together an evaluation that had a number of different tasks, and these tasks get more and more complex and more difficult as the test continued. And so, some of the early tasks are things like tracking light, so sort of having a light and sort of having, this would be very young kids, seeing whether or not kids could follow directions and track lights. Things like repeating sentences, memorizing things, sort of giving definitions, different reasoning problems, etc. And so a big group of questions. Have everybody going through and do this. And as you progress through the test, it got more and more difficult. Okay. And what Binet did, which was really smart, took a huge sample of kids with lots and different variability. So kids who were on the high end, sort of very gifted, kids who struggled a whole lot, and then sort of everybody kind of in the middle, to go through and see 4 different ages, how far did kids generally make it through this series of tasks. Okay, and what Binet did was use this to determine a child's mental age. Okay, and the mental age, as originally, you probably heard about this, mental age as originally conceptualized involved the performance of anybody taking the test relative to an average child of that age. Okay, so later on, what Binet did, or sort of, a Stanford psychologist included, sort of extended this beyond elementary school kids to look at adolescents and adults, and this became the Stanford Binet intelligence, the Stanford Binet IQ test. Okay, and so the original IQ, right, the original intelligence quotient, used this Binet's concept of mental age. And IQ was calculated as someone's mental age, sort of where they performed, sort of their score, where their score fell on that trajectory, right, relative to their chronological age multiplied by 100. Okay, so what we do to calculate, and this isn't how we calculate IQ anymore. This IQ is scaled completely differently. But at the time, right, the idea is we would take individual's mental age, divide it by their actual age, multiply it by 100, and that would be your IQ. Okay, so let's say a child comes in, they're 9. Okay, and I go through, have them perform the Simon Binet evaluation, have them take the IQ test, and this person is performing at the level of an average 9-year-old. This child also happens to be 9. If we take 9 by 9 divided by 100, or 9 divided by 9 multiplied by 100, we get an IQ score of 100. Okay, and this is why we have average IQ scores. So average IQ, if we were to go through and take a validated test, give it to, say, 5,000 people, what we would see, if it was a representative sample, we would see average score right at 100. Okay, and this originates, the origin of that scaling originates from the original intelligence quotient, taking the mental age from the chronological age. Okay, but let's say instead we get someone. Okay, and what we see is this child, who I'm seeing now, is performing at the level of an average 9-year-old. Okay, but this child's physical age, they're only 7. Okay, so they're performing where we would expect a 9-year-old to perform, but they're only 7 years old. If we take 9 divided by 7, multiply that by 100, we get an IQ of 129. Okay, so this is someone who's performing above average, right? They're 7, but they're operating at the average of a 9-year-old, and so we have a higher IQ here. Let's say we get another person, they're performing at where we would expect an average 9-year-old to perform, but this time this child is 12. Okay, what we would do again is take their performance, sort of where that is, normative to relative to other kids, divided by their actual age, and it would give us an IQ of 75, which is obviously going to be less than sort of average here. Okay, so this was the original conceptualization of IQ. This is where IQ developed, and for Binet's sort of original sort of purpose and things like that was pretty compelling and some groundbreaking stuff at the time. Okay, but limitations. The first time out, we're never going to get it all the way right. It was a decent system probably for what Binet was trying to do at the time, but some limitations, big concepts with the problems with the concept of mental age. This idea of mental age is still sort of around. People will talk to it. They say, oh, this person, you see it in law enforcement or sort of things, people say, oh, this person committed this crime, but they have the mental age of a 10-year-old or something like that. That's not how it works. There are ways to go through and assess stuff. But the big issue with mental age is if I'm going through, and again, if you've got young brothers and sisters, cousins, kids of your own who are sort of really little, elementary school, if this kid is, I don't know, how old is that kid? 2, maybe? I don't know. Let's say that kid's 2. And then this kid's, say, 5, something like that, right? Huge jump in this, right? From 2 to 5, that's 3 years. Massive increases in intellectual ability and sort of performance on different types of tasks. But if I take this guy, let's say this guy's, I don't know, 30, and this guy's 33, this idea of mental age starts to fall apart as soon as we get past sort of early elementary school, right? And so we've got this problem of mental age is not a linear function over the course of the lifespan. Again, Binet was just early sort of working with elementary school kids, and so it was sort of maybe okay there. But now if we're thinking about IQ as something that generalizes across the population, some issues there, okay? We also see that our scores on these assessments are impacted by a number of different factors outside of just your innate ability, right? And that's generally what we think IQ is. We found this to be fairly stable and has a huge genetic component. But if I sit a bunch of people down and have them take an IQ test, there's other things outside of their innate ability that's going to go through and impact that. So we've got cultural factors, okay? And these assessments are developed by investigators from white Western culture, there's certain aspects of the test and certain information that starts to be more culturally loaded in some ways, and we'll talk about that. So example, if I say, who is your aunt? Let's say I'm sort of asking sort of 6-year-old, right? And one of the questions is, who's your aunt? And that's intended to assess your sort of understanding and comprehension of terms and things like that. Well, if I'm from white majority society, I might say, oh, my aunt is my mom's sister, my dad's sister, something along those lines, right? And that's generally what's expected to be sort of the right answer. But if I'm from certain cultures, aunts use more broadly, right? Aunt can mean family, friends, sort of other sort of folks, right? Oh, this is my aunt so-and-so, when in fact they're not a blood relative. And so if I'm a child from sort of a culture where aunt is used more broadly, what I would get that wrong. It doesn't mean that I don't understand aunt. It's just within sort of my community, sort of my culture, so the use of this word is used more broadly. And so I wouldn't get that right. And so I would get dinged, not because I'm not as good as other people. It's just because there are cultural factors that start to play in. Okay. Education is also a thing, right? And we talked about this, about early access to good schools starts to help interacts with intelligence, right? If I'm very high performing and I have access to good education, I might be farther on. Even if I'm sort of average, but I have access to good education, I might perform better than someone who's actually has a greater intellectual capacity than me, but hasn't had a lot of good educational opportunities, right? And so we see this a lot in individuals from impoverished communities, things along these lines. We start to see lower scores, and a lot of that is going to be access to education, right? And now with these intelligence tests, there are aspects that are nonverbal, that are assessing aspects of performance that aren't based on sort of your learning and things like that. And what we sometimes see is discrepancies in different subsets of IQ for individuals who may be quite brilliant but just haven't had access to proper education. We start to see deviations really high in some of these nonverbal areas, and maybe doing less well on things that involve like vocabulary, general knowledge, things like that. Okay. We also see scores impacted by effort. I can tell you, my wife is a school psychologist, so she does a lot of sort of evaluations with young children. And so while she was going through her program, I was the guinea pig, the dummy, to sort of help her go through. These are really, really tedious. And sometimes, obviously, people are going to get fatigued. If I'm not giving full effort or I'm not taking it seriously, I'm going to get lower scores. And so effort is something that we need to be thinking about as well. Okay. Other thing that happens, sort of darker, is early on. So remember that Binet was developing this idea of intelligence and measuring this stuff at the turn of the 20th century, or sort of the beginning of the 20th century. Well, there's a lot of pretty nasty stuff going on beginning of the 20th century, okay? And people caught on to this idea of intelligence, and some of the stuff from Darwin and thinking about sort of natural selection, and sort of people started to roll these two things together. And in the early 20th century, there was something known as the eugenics movement, right? And the eugenics movement advocated that we could advance the human species through selective reproduction. That means what we're going to do is we're going to find people who are smart and have them have children with other people who are smart. And if we did that, then the human race would get smarter and smarter and smarter. But if you were not smart or deemed not valued in some way, then sort of the idea was that your options for reproductive success were limited. Obvious problems with this, right? And again, this was a big part of the Nazi movement in Germany. post-World War II atrocities sort of understood about all this stuff. And so eugenics kind of fell out of favor after that to some extent, right? But there are people who still sort of advocate for this type of stuff. But post-World War II, people starting to recognize that advanced to its logical conclusion, some really, really bad stuff going on in terms of human rights with eugenics stuff. Okay, so Benet's early work, groundbreaking, fantastic in a lot of ways, but sort of obviously some limitations with this. Okay, so how do we understand intelligence or intellectual capacity, right? If we're thinking about this, if we're working in psychology, we want to know not just, oh, hey, this is a thing. We want to know what it works. How does it all fit together? And so many different theories of intelligence over the course of early development by Binet. But one of the first theories of what was actually going on was a theory known, involved what was known as Spearman's G. Okay, and what Spearman proposed is that we're born with some intrinsic mental energy. Okay, and this mental energy was signified by G. And the idea is that this well of mental energy accounted for people's performance across a number of different types of tasks, like the tasks that Binet was having people do. And so if in this graph, you can think about if these are sort of different tasks. So let's say S1 is your vocabulary, and S2 is general knowledge, and S3 is problem solving, and S4 is your ability to sort of rapidly process math or something like that, right? Within Spearman's theory, this G, this mental energy was driving performance, because if you're good in this task, we generally see you're good in this task, and you're good in this task. People who tend to be good in sort of one domain tend to be good higher or in other types of domains. And so what Spearman proposed was that this is, and Spearman identified this as like an actual physical strength, like a muscle, like something that you could actually sort of like a real biological thing, right? This strength, this mental energy was driving performance. So this is the well, and it's driving performance here and here and here and here and here and here and here across all these different things. So in the original Stanford test, right, you're doing different tasks, and those tasks are getting harder and harder, but your performance across each one of those are going to be correlated with one another, associated with one another. People who tend to do high in one domain tend to do high in others. People who struggle in one domain tend to struggle in others. And so Spearman proposed that it's this G, this sort of mental strength or this mental energy. Okay. Now, this is a super influential theory and still sort of has influence on more modern theories today, but limitations is at the time Spearman like literally conceptualized G as sort of a real, like a physical, like an actual mental thing, right? This idea that it's like a muscle or a strength, like it's a biological, like it's an actual, like we could grasp it, see it, sort of hold it type of a thing, right? We've been looking a long time. There's not one part of the brain that holds G, right? It's a much more complex kind of abstract concept, right? But Spearman thought about this, and again, early on as an actual kind of a physiological thing, which turns out not to have much evidence for, right? And the other thing that happens is we see our intellectual abilities, things that we typically go into the assessment of intelligence, more complex than what's specified in this model, but good in a lot of ways in terms of sort of proposing sort of a general model. Okay, so this is Spearman's G. The other intelligence theory that caught a lot of traction, people love this, is Gardner's multiple intelligence, right? And this was generally sort of Gardner's was a reaction to Spearman's and sort of this sort of research following the tradition of Spearman's G. And what Gardner proposed is instead of one thing, right? So Spearman said this G factor is driving all of your performance down here. Gardner didn't like that. And a lot of people don't like that idea, right? Because it assumes that different people have differing levels of this sort of G factor, which make them either good or not so good across a whole range. Gardner thought that that was not a good way to think about things, and so instead proposed a model that hypothesized 8 autonomous competencies, right? And so Gardner said, there's not just one G, we have multiple sort of sources of intelligence. Different people are good at different things, and it's not like sort of everything sort of rises and falls with this G. And so now there's subsequently been lots and lots and lots of different theories of multiple intelligence. We got 8, 10, 12, 16, 20. It gets kind of out of control. But Gardner's original theory had this naturalist ability. And so this was the ability to see objects in nature and sort of adapt to nature, things along these lines. So my brother's a biologist for the state. He works with large carnivores, bears, and sort of mountain lions and stuff like that. He manages to go out there and do that without getting eaten. I would get eaten immediately because I am animal blind. So I go out and just kind of walk around in my own head. My brother, a much stronger naturalist intelligence than me based on Gardner's theory, right? We have mathematical intelligence, linguistic intelligence, interpersonal intelligence, sort of the ability to sort of interact with others, intrapersonal intelligence, sort of the ability to know my own thoughts and feelings and sort of recognize what's going on inside of me, spatial intelligence, my ability to sort of go through and sort of see things in space and sort of put things together, maybe sort of artistic stuff, musical intelligence, kinesthetic intelligence. If you're sort of those, when we're watching professional athletes or sort of some of you amateur athletes, able to sort of know where your body is in space. Think about an Olympic diver, right? The ability to go to a board and sort of jump off a diving board or a platform and know where your body is in space and be able to manage it. Again, if I tried that, belly flop. Doesn't matter how often I tried to in practice, it would be not as good as someone who sort of has this kinesthetic intelligence, okay? And so Gardner's multiple intelligence said, G is nonsense. There's no one intelligence. There's multiple intelligence, and sort of different people can have different strengths, okay? People love Gardner's multiple intelligence. Love it, love it, love it, right? And it makes us feel good because like, there's different people have different strengths, which is absolutely true. The problem is it doesn't map on to sort of what we see in terms of research, in terms of like actual intellectual ability, okay? What we tend to see when we're looking at things that are sort of traditionally identified as intellectual abilities, they tend to be higher, or so they tend to be higher or lower sort of together. There's correlations. It's not separate. Gardner's multiple intelligence says this is separate than this, is separate than this, is separate than this. But when we're actually looking at things that sort of generally are agreed upon that sort of focus on this, we see that they're correlated, they're associated, things along those lines. If I have a huge vocabulary, I'm generally sort of probably pretty good at general knowledge. I'm probably pretty smart or fast at processing things. I can probably sort of hold a lot of information in my brain all at the same time. Gardner's theory doesn't account for this, right? And then the other thing is probably the biggest criticism here is the conflation of talents with intelligence, right? And this is where people get really worked up. We in our Western society, we put sort of this sort of really intense focus on intelligence, right? And so people tend to sort of maybe prioritize intelligence over other types of skills. Gardner is recognizing that different people are good at different things, but the problem is, from a scientific standpoint, we start to get pretty loose on sort of what constitutes intelligence and what's just talents, right? And so you can see this as these models get larger and larger. You get 40 intelligences, or 20, 12, 15, 16, 20 intelligences. Where do you draw the line, right? And so probably what they're doing is identifying things that people are good at but aren't actually sort of tied in real well with this idea of IQ or intellectual capacity. So people love Gardner's theory. It's just there's no real empirical support that this is actually how things work out. Yeah. Hierarchical model. Okay. Carroll has sort of maybe one of the more modern and sort of agreed upon, or sort of not universally agreed, but is one of the more influential models And you'll see that this looks a lot like Spearman's original G model here, okay? So Spearman's G, we have G, this innate mental ability driving performance on all these tasks. Carroll still keeps this idea of G. Now, it's not, Carroll's hierarchical model doesn't identify this as sort of an actual physical strength. It's just sort of some innate ability, right? So it's not like a physical muscle, or thinking about it as like something that's I can necessarily touch or hold, but recognizing that some people are sort of that people vary in terms of G here, and this is kind of what we would think about as your IQ, but what this does is it drives performance in a number of different domains, okay? Now, you don't need to worry about or memorize all these different domains. Not important, but what you do want to do, what I do want you to do, is think about sort of recognizing that instead of just G performing G driving performance across all these tasks that you're actually doing, that I'm observing, we see that G drives a number of different domains, things like fluid intelligence. So this is reasoning and other types of activities that are minimally dependent on learning. So even if you didn't go to a good school, we would see sort of performance on fluid intelligence tasks probably to be quite high. Crystallized intelligence, this is going to be mental processes that involve the effects of experience and learning, okay? So if you've got good schooling, what we would see probably sort of higher levels of information sort of on just, I know things, I've sort of been exposed to things, and we would see higher performance on these tasks. General memory and learning, this is, again, sort of your ability to memorize things, and so your ability there. Broad perceptual or broad visual perception. This is your perception, discrimination of visual forms, being able to say this is similar to this is different than this. Broad auditory perception, same type of thing, your ability to distinguish between different sounds. Broad retrieval ability. This is your ability to retrieve concepts and information from long-term memory. So I tell you something, then later on I follow up on it, your ability to pull that out. Broad cognitive speediness. This is your processing of complex information. If I give you a bunch of tasks to do simultaneously, your ability to go through and sort of work that all together. Processing speed, this is going to be reaction time, speed of decisions. And so instead of just instead of G driving all of this straight into this, what hierarchical model says is G does drive performance across these domains, but then these domains are reflected in sort of the individual tasks that we would do in your IQ test down here. Okay, so again, Carroll's theory still relying on this idea or this concept of G, but just recognizing that it's much more complicated and it's not an actual physical thing. I can't sort of give you a brain scan and see your G. Okay, so last thing we need to talk about. Remember that I had said that IQ is always based on your performance relative to some normative population, right? And when we're talking about normative populations, what we're talking about is standardization, okay? What we need to do with these scores is, in order to get good and valid and reliable scores, we need to give these evaluations to lots and lots and lots and lots and lots of people. And when we do that, what we find is that performance generally falls along a natural curve, kind of this bell-shaped curve right here. Okay, and what we know is we can, sort of with the types of development and validation that go on with these types of exams, what we can do is you or I go in and we take it, and we know that we're going to fall somewhere along this curve. So let's say you and I go in and we score, say, 100, 105, right? What we know is based on the way these are normed, a score of 100 is the average. So if I'm 105, so I'm just kind of average. If I'm sort of a little below, say 95, again, I'm average. We see that about a little over 2/3 of the population is going to fall between a score of 85 and 115. And we generally think about this as average range. But as we get farther out, a smaller number of people are going to fall somewhere between, sort of down between 85 and 70, or 115 to 130. If we look at the total number of population, total number of people ranging from 70 to 130, this gets about 95% of the people, right? As we go farther out, we get smaller and smaller regions. So up here, very, very small numbers of people, very unlikely that if you were to go in that we're going to score up here, or also down at the low end, down on this end. Okay. And so what we can do though with these tests, the way they've been standardized, you or I, anybody else can go up, and as long as we're giving good effort, we're doing our best, and sort of paying attention, what we can do is look at and sort of tell where we score relative to sort of the normal sort of average everyday person falling along this bell curve. Okay. Which brings us to issues of reliability and validity with intelligence testing. Okay. If we're talking about reliability, if we want a test, and particularly for something that's pretty high stakes, right? Like you go and you get an IQ test, like there's, like I said, there's a lot of weight that gets carried on that sort of unnecessarily. So people get really fixed on this number, right? But these evaluations are very important for a lot of different reasons, making sure that people are getting accommodations and sort of if we're going to go through and try and diagnose different difficulties that people may have, right? And so what we want is we want these tests to be both reliable and valid. And reliability and validity are two different things. Okay. Reliability, this is the extent to which an assessment provides consistent results. If I have a test that's reliable, what I want to do is I want to be able to give that test again and again and again and again and again. And every time I give it to people who are sort of about the sort of equal, we want the same scores to come up. So if you came in and I had you take sort of different versions of the same exam over and over and over and over again, I would want you to fall about in the same range every single time I went through and gave you that. And if that happened, we would say that that was a reliable test. Okay? Validity, however, is the extent to which an assessment measures the thing that we want it to assess. I can have a reliable test, right? That goes in and I get the same score every single time, but it might not actually be measuring the thing that I want to measure. Let's say I want to measure intelligence, okay? And my measure, let's see, not intelligence. Let's see, I want to measure speed, how fast you are. That's what I'm interested in. I want to measure people's athletic ability. Okay. And so what I do is I have you come in and my measure of athletic ability is your shoe size. And so my theory is that people with more athletic ability have bigger feet. And so what I do for my test of your athletic ability is I bring you in and I measure your shoe size. That's probably going to be a reliable test because every time you come in, if I got a good sort of measuring tape, right, or sort of scale or something like that, right, I can measure your foot size reliably. Every time you come in to get your foot measured, it's going to be about the same size, right? So I've got a reliable test. It's just not a valid test because foot size doesn't actually measure athletic ability. And so what I've got is I've got a reliable test that's not valid, right? Validity is an index of the extent to which sort of I'm getting at the actual sort of construct, right? That I'm measuring what I think I'm measuring, right? And so if I wanted to measure athletic ability, what I might do is look at, let's say, whether or not you lettered in varsity sports in school, right? Now that's not a perfectly valid measure because lots of athletic people aren't in high school sports, but it starts to be more valid than your shoe size, right? So validity is the extent to which we're getting at sort of what we actually intend to get at, that we're measuring what we think we're measuring, okay? And so a nice way to think about this is think about target practice, okay? So if here I go through and I shoot, 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 and I shoot. I'm getting a tight cluster here, right? So I would say here, I've got a reliable, I'm reliable, but I'm not valid, okay? I'm reliable. I'm sort of coming in all in this same sort of area, but if this is where I want to be, and this is where I'm shooting, I'm reliable. I'm just not valid on that. I'm not on target, okay? But let's say we come in sort of different target, different person coming in here, and I'm going through, I've got a pattern, right? Generally, I would say I'm reliable. If I take the average of all these points, it's kind of centering around where I'm wanting to get at, right? So I'm generally valid. I'm kind of, so think about this as sort of the extent to which sort of people are, sort of how many high school sports people lettered at. I'm sort of shooting all over the target. In general, I'm kind of getting at sort of where I want to be, but I might not be sort of reliable. Well, that high school sports isn't, that's not a reliable sort of issue. But in this target here, right, I'm kind of centering around where I want to be, but I'm not reliable. I'm kind of, each shot is kind of all over the place, okay? But if we're in this last target, we're here, 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 whoops, right there, right there, right there. Oh, got away from us, right? In general, ignore that guy. Up here, right, what we've got is something that is both valid and reliable. Here, every time we're scoring, we're all scoring in the same area, so we're very tightly clustered. Our scores are all right on target. This would be something that would be a test that's both valid and reliable. Okay, so people will use these interchangeably, but make sure that you know reliability, validity, different things. Reliability, making sure that every time I'm sort of testing something again and again and again and again, I'm getting the same score, right? But that doesn't necessarily mean that I'm valid. I can also be valid, but not terribly reliable. What we're shooting for is high levels of both validity, reliability, again, particularly when we're doing something like assessing intelligence or intellectual ability, again, because of the stakes that are often involved. Okay. All right. Lecture summary, make sure that you go through, take a look at this. Comprehension check, make sure you go through, take a look at this. If you have any questions, make sure to get in contact. Let me know. Happy to help you out. Again, apologies for having to sort of delegate this one to video lecture, or, well, not live lecture, but we'll get picked up tomorrow with stuff on thinking and learning and stuff like that. So, all right. Thanks, everybody, and we'll see you tomorrow.